Hello and welcome back to my channel. In this video, we will be looking at the influence of relief on local climate in the Caribbean. Now, if you have not yet subscribed, go ahead and click the button below. Climate is the average condition of the atmosphere, usually calculated over a period of 30 to 35 years. Climate is mainly experienced in the lowest layer of the atmosphere called the troposphere. Now, when we study weather, we look at 7 weather elements. When it comes on to climate, we mainly focus on 2 main elements, which are temperature and precipitation. Of course, we can study other elements, but these are the 2 that we focus on. And we can actually use a graph to represent these 2 elements so that we can have a better understanding of climate. We call this graph a climate graph. The climate graph consists of a bar graph which shows rainfall, average rainfall conditions, and a line graph which shows average temperature conditions. Now, most Caribbean countries generally experience a tropical marine climate. However, within each country, there are variations in the climate due to local factors. And one important local factor that causes variation in the local climate of Caribbean countries is relief. Relief refers to the height and the gradient, as well as the shape, etc., of the land. Caribbean countries vary in their relief. Territories such as Bahamas, Antigua, and Barbados are generally low-lying, so there is little variation in their climate resulting from relief. However, there are other Caribbean territories such as St. Lucia, Dominica, and Jamaica, where the relief is much higher. And in these countries, there is a noticeable difference in the local climate between highland areas, which are mainly found in the interior, and lowland areas, which are often found along the coast. So let us first examine the impact of relief on temperatures. Atmospheric temperature refers to how hot or cold the atmosphere is. The troposphere is not directly heated by the sun. Instead, the sun's radiation is emitted to the surface, which in turn absorbs this radiation and in the process heats up. The surface then re-emits long-wave infrared radiation, which is then absorbed by the atmosphere. And of course, this is mainly the result of greenhouse gases in the atmosphere. I will be putting out a video soon about these greenhouse gases, so look out for that. The denser the atmosphere, the greater is its ability to absorb radiation from the sun. Sorry, from the surface. From the surface. Temperatures decrease with height above sea level. Temperature decreases at a rate of about 6.4 degrees for every 1,000 meter increase of elevation. So what this means is that lowland areas have higher temperatures than hilly areas. So for example, in Jamaica, the Blue Mountain is located at a height of 2,229 meters. Kingston is located at sea level. And this therefore means that the Blue Mountain peak is about 14 degrees cooler than Kingston. Hilly areas have smaller land surfaces, as you can see in the diagram before you. And it means that if they have smaller surfaces, they are therefore going to be emitting less long wave energy. And in addition to this, the further up you go in the atmosphere, the thinner the atmosphere becomes, and therefore this reduces its ability to absorb heat from the surface. So not only is there less heat being emitted because of the smaller land surface, the atmosphere has a lower or lesser ability to absorb the smaller amount of heat that is being emitted. So these will contribute to the temperature being lower in hilly areas when compared to lowland areas. All right, let us now look at the influence of relief on rainfall conditions. Now, as winds blow across a mountain or a hill, they are met with the barrier of the mountain or the hill, and they cannot go down, they cannot turn back, and therefore they are therefore forced to rise. Now, as they rise, the air will get cooler and it may cool to its dew point. Remember that the dew point is where the air is holding all the moisture that it can hold, or in other words, it is saturated. So dew point will be reached even faster if the air had a high level of moisture in it to begin with. So if after dew point is reached, more cooling takes place, then this is going to lead to condensation. And in the process of condensation, water vapor is going to be converted to water droplets and clouds will be formed. Now, this situation is true of Jamaica, where the prevailing wind, which is the northeast trade winds, which generally would gather a lot of moisture as they blow over the sea. When they reach to the Blue Mountains, they will be forced to rise and in the process cool and condense to form clouds. Now, when clouds are formed, this will, in most cases, lead to rainfall formation. And this type of rainfall is known as relief rainfall or orographic rainfall. All right, this is just one of three main types of rainfall, the other two being frontal rainfall and convectional rainfall. So in this case, where the rainfall is the result of a relief barrier, we call it relief rainfall or orographic rainfall. Now, after losing its moisture, the air will begin to descend on the opposite side. And as it descends, the opposite will happen. As it descends, it will start to warm up. And as it warms, the relative humidity will decrease. And therefore, it's getting further and further away from its dew point, which means that either no cloud at all or very little clouds will be formed. It means that conditions on this side of the mountain will be generally stable. It will be dry and sunny. Now, the side of the mountain or hill where the wind is rising and there's a lot of wind is called the windward slope. The opposite side where the wind is descending is called the leeward slope. And because the area on the leeward side is generally dry, it is called a rain shadow. So Kingston in Jamaica is a good example of a rain shadow. All right. Even though we said that rainfall rather, and temperature are the two main elements, let us also look at winds for a moment. Winds will also vary from highlands to lowlands as a result of relief. In general, wind speeds will increase with height within the troposphere. And this is because the pressure gradient also increases with height. Friction is a force that influences wind speed, and friction is generally greater at the surface but decreases with height. And so winds at the surface will be reduced due to friction, but at higher levels where there is less friction, the winds will be stronger. Another factor that influences the wind speed is the fact that the air is of a lower density the further up you go. And the lower the density of the air, the easier it is for the air to move. All right. So that is another factor influencing the wind. Also, let us remember again that on the windward side, we have stronger winds, and on the leeward side of mountains, the wind speed will be weaker. All right, before we end this video, let's look at a few past paper questions. So the first question says, explain why temperature is usually much lower on the summit of a mountain than on the surrounding lowland. And this question is worth 4 marks. All right. So to answer this question, we want to give about, 4 strong points. First of all, we need to mention the fact that within the troposphere, the sun heats the surface, and that it is the surface in turn that is responsible for heating the atmosphere above it, which means that places closer to the surface will have higher temperatures because they are closer to the heat source. We could also mention that the air gets thinner the further up we go. So air at higher levels will be unable to absorb a lot of heat or as much heat as the air at lower levels. And of course, we could also mention the fact that the land surface is smaller the further up you go. All right, let's look at another question. This one says, explain why winds at the same elevation are warmer on the leeward side than on the windward side. Now, the main thing to remember for this question is that air rises on the windward side and sinks on the leeward side. And as it rises on the windward side, it is cooling while it is getting warmer as it descends on the leeward side. All right, so that will definitely give reason why the leeward side will always have a higher temperature than the windward side. Okay, and that's for 3 marks. So you just need to say that clearly, and I'm sure you'll get your 3 marks. All right. This other question says, explain what happens when warm, moist air is forced to rise over a mountain. All right. So the reason uh, why you should study with diagrams is that the diagrams will help you to remember the steps that are involved. So remember that as the air rises, it is going to also get cooler. The reason it's getting cooler is because the pressure, it is encountering lower and lower pressure, and that is causing it to expand, and as it expands it uses up some of its energy to expand. This is why it cools generally. All right. So we know why it rises in the first place. It rises in the first place because it encounters the mountain slope and has no other place to go but upwards. And then as it rises, it cools. We also know why it cools. When it cools sufficiently, it will reach to its dew point, and at its dew point, it is holding all the moisture that it can hold. Now, in the question, it talks about moist air. So the fact that it is moist already will mean that it will get to its dew point even faster. Uh, if it is cooled even further, then condensation will occur, and we know that condensation leads to cloud formation, and the clouds will produce rain eventually. All right. So you just need to write that clearly, and again, you will get your full marks. All right. So the last question we are going to look at says, explain why mountainous regions usually have lower temperatures and higher rainfall than surrounding lowlands. And this is for 8 marks. Don't be intimidated by the 8 marks. Notice that unlike the other questions that focused on a specific element, this one is asking about the 2 elements of climate, and therefore, more than likely, the way this will be graded, you might be given about 4 marks for talking about temperature and 4 marks for talking about rainfall. Bear in mind that this is a comparison question, so you need to show at all times the differences between the highland areas and the lowland areas as you talk about the temperatures and the rainfall conditions. Another point, remember that this is an explanation question, which means that you are expected to give the reason. So what you could do is to state the differences clearly, the differences in temperatures, the differences in rainfall, and as you do so, give reasons for these differences. All right, so this is where I will stop for now. If you have not already, uh, go ahead and like, share, and subscribe to my channel.